Hello everyone. This class is going to be a repeat of the Saturday class for FIN3701. This class was held on the 7th of March, and I'm just going to take you through the important concepts that were touched upon in this Saturday class. So on Saturday, we continued with study unit 2, which is capital budgeting techniques, and we were left with one part on study unit 2, which is NPV profiles. So if you remember, in the previous weeks, we had looked at the different capital budgeting techniques, calculations involving how to do the net present value, how to do the internal rate of return, how to do the IRR, the profitability index, and the payback. And I had also touched on some theory associated with those techniques. So the last thing we were left with in that chapter is NPV profile. So today I'm going to take you through NPV profiles. And after taking you through NPV profiles, I'm also going to take you through study unit 3, which is risk and refinements in capital budgeting. And then we'll be finished with topic 1. So remember, topic 1 can be split into 3 study units. We've done capital budgeting cash flows. We've gone through capital budgeting techniques. And I want to finish one section on capital budgeting techniques. And then lastly, I'll look at risk and refinements in capital budgeting. Okay. So first and foremostly, we have something very important in FIN3701 and in financial management that we call an NPV profile, And we define an NPV profile as a graph or a table showing how the net present value of a project changes for different discount rates. So when we say NPV profile, we're simply talking about a graph or a table showing how the NPV of a project changes for different discount rates. So this table that I have right here is an example of an NPV profile. As you can see, we're given 2 projects. We're given project A and we're given project B. And for these 2 projects, we're given different NPVs for different discount rates. For example, the NPV of project A is 200,000 Rand when our discount rate is 10%. The NPV for project B is 195,000 when our discount rate is 10%. At 11%, A has an NPV of 190 and B has an NPV of 180. At 12%, A has an NPV of 0 and B has an NPV of 80. And lastly, at 13%, A has a negative NPV of -10 and B has an NPV of 0. So this is just a table showing us how the NPV of 2 different projects change as we increase discount rate. So we call this an NPV profile. And as you can see, as we increase our discount rate, our NPV decreases. So that's an important relationship. Whenever you increase your discount rate, your NPV decreases. So this is an example of an NPV profile. It's a table just showing how NPV of a project changes for a change in discount rate. We can also illustrate this relationship through a diagram. So in this diagram, we have, it's also an NPV profile. Remember, we said it can be a diagram or a table. In this diagram, we have the NPV on the x-axis, sorry, on the y-axis, NPV, and we have the discount rates on the y-axis. So this line is showing the NPV of project A. It's showing us that as we increase our discount rate, as our discount rate increases, our NPV is going down. And on the same diagram, we also have this dotted line. This dotted line is showing the NPV for project B. And it's telling us that as we increase our discount rate is shown on the x-axis. As we increase our discount rate, the NPV of the project is going down. So this is just a table illustrating the NPV of two different projects and how the NPV of these two different projects is decreasing as we increase our discount rates. We call this an NPV profile. So the bold line is for project A, and the dotted line is for project B. Now, if you notice here, where the bold line for project A is crossing the x-axis, we have the internal rate of return for project A, which is 12%. And here, where the project is crossing the x-axis, we have the internal rate of return for project B, which is 13%. Remember, the internal rate of return is the discount rate at which the NPV of a project is 0. So you can notice that graph B crosses the x-axis at this point, and graph A, project A crosses at this point, and project B crosses at this point. So the internal rate of return for project B is 13%. That's where our NPV is 0. That's the discount rate. That gives us an NPV of 0 for project B. And here it's 12%, and that's the discount rate. That gives us an NPV of 0 for project A, right? So these two, this table is an NPV profile in tabular form, and this graph is an NPV profile in graphical form. So an NPV profile is just a graph or a table showing us how the NPV of a project changes with discount rate. Now, this NPV profile can be used to prevent conflicts in ranking. Remember, last week we discussed what conflict in ranking is. We said conflict in ranking occurs when you are comparing two or more projects, but to just keep it simple, I'll say two projects. Conflict in ranking occurs when you're comparing two projects, and then these two projects give you different ranking when you use the NPV and the IRR. For example, conflict in ranking might occur if NPV says choose project A, whereas IRR says choose project B. So these NPV profiles, especially this graph can help us to prevent conflict in ranking. And I'm going to illustrate this explanation to you through these three observations right here. Okay. So let's look at this graph. Let's just go through this graph. Let's say we use a discount rate less than 15%, maybe a discount rate between 0 to 15%. Let's say we use a discount rate of 9% to discount our NPV, a discount rate less than 11.5, let's say 9%. You'll notice that if we use a discount rate less than 11.5, the graph of project A is higher than the graph of project B. This means the NPV of project A is higher than the NPV of project B. So as long as we use a discount rate which is less than 15%, the NPV of project A will be higher than the NPV of project B, right? So that's the first observation. Let's look at a second observation. Let's say we use a discount rate greater than 11.5%. Let's say maybe we use 13%. If we use a discount rate greater than more than 11.5%, you notice that the graph of B is now higher than the graph of A. the graph of B is on top of the graph of A. So this means the NPV of B is higher than the NPV of A if we use a discount rate, which is found somewhere here, which is higher than 11.5%, right? So you see, using less than 11.5, we're getting a different answer. We get A being higher than B. Using more than 11.5, we're getting B being higher than A, right? The third observation is that for all discount rates, the IRR of B is more than the IRR of A. Remember, the internal rate of return is not affected by discount rate. This amount is fixed. It will always be the same. NPV is the one that's affected by discount rate. So the IRR of B will always be higher than the IRR of A, right? So the last observation is something that doesn't depend on whether we use a discount rate, which is less than the crossover point or more than the crossover point. The IRR of B is always higher than the IRR of A. So clearly we can see that observation number 2 and observation number 3, they give us the same answer. If we use a discount rate more than 15%, 11.5%, sorry, if we use a discount rate more than 11.5%, the NPV of B will be higher than the NPV of A. And this is also consistent to what the internal rate of return is telling us. Okay, so there is no conflict of ranking here. But if we use a discount rate less than 15%, we get the NPV of A being higher than the NPV of B, but the IRR will give us a different ranking. The IRR will say the internal rate of return of B is higher than the internal rate of return for A. So clearly we can see that using a discount rate less than 11.5%, using a discount rate less than the discount rate at the crossover point will lead to different recommendations by the NPV and the IRR. Because we see the NPV of A is greater than the NPV of B if we use a discount rate less than 11.5, whereas for all discount rates, the IRR of B is higher than the IRR of A. So there's a conflict. However, if we use a discount rate more than 11.5%, we get that the NPV of B is higher than the NPV of A, and this will also be the same with what the IRR is telling us for all discount rates, that the IRR of B is higher than the IRR of A. So if we draw an NPV profile, if we determine the crossover point tells us that we need to use a discount rate greater than the one at the crossover point, such that the IRR and the NPV both give us the same recommendation. Okay, so conflict of ranking can help us. In conclusion, conflict of ranking can be prevented by using an NPV profile. If you choose a discount rate which is greater than the one at the crossover point, the NPV and the IRR will both give you the same answer. However, if you use a discount rate that is less than the one at the crossover point, you will get a different recommendation for the NPV compared to what you get for the internal rate of return. Okay, so that's the first and very important point that we covered on Saturday, which is NPV profile. So that finishes capital budgeting techniques, which is study unit 2. Lastly, we looked at study unit 3, which is a very important study unit. It finishes off topic 1, and it's known as risk and refinements in capital budgeting. Risk and refinements in capital budgeting. So firstly, when a project is riskier than usual, we can use a different discount rate to discount the cash inflows. When a company wants to choose between 2 different projects, it's possible that one project might be riskier than another project. When projects have different risks, you can't use the same discount rates to discount those projects. You have to use different discount rates. discount rates are a measure of risk. So when you're comparing two different projects, like the projects we've been looking at before, let's say you're comparing project A and project B. If project A is riskier than project B, it means you have to discount project A with a higher discount rate compared to project B, right? And the next point says the higher the risk of the project, the higher the discount rate should be. So if a project is risky, you should discount it with a higher discount rate. So this discount rate is a measure of risk. Therefore, if comparing two different projects, the riskier project should be discounted with a higher discount rate when calculating NPV. So we can use what we call the risk-adjusted discount rate. This is really important. We can use the risk-adjusted discount rate, known as the RADR, to discount cash flows from risky projects instead of the cost of capital, right? So let's say you have a risky project and it's riskier than the projects you usually do as a company. If you want to calculate the NPV of that project, you have to use what we call the risk-adjusted discount rate. You can't use the ordinary cost of capital. So you need to use the risk-adjusted discount rate to discount the project. So this is to compensate for risk. Remember, if a project is just average risk, like let's say the projects we've been looking at so far, they were just average projects. We've been using the cost of capital and one discount rate to discount all the different projects. But when these projects start being riskier than the average projects, we can no longer use the cost of capital. We rather have to use the risk-adjusted discount rate. So the general formula to calculate this risk-adjusted discount rate is given right here on the screen. The risk-free rate plus the beta of the project multiplied by RA minus RF. RF is known as the risk-free rate. RM is known as the return on the market or market index. B project is known as the beta of the project and it's a measure of risk. The higher it is, the riskier the project is. And RM minus RF is known as the market risk premium. So in a question, if they say the market risk premium, it means they've already subtracted RM minus RF for you if they say market risk premium. But if they say return on the market, it means that they've only given you RM. They've only given you RM, okay? So when a project is risky, you have to calculate the risk-adjusted discount rate, and then you have to use this to calculate your NPV. So let's just look at an example to see how this might actually happen in the exam or in an assignment. Here it is. Here's an example right here. So we're told to consider two projects. We've got project A and we've got project B. And you're told you have an initial investment of 100,000 Rand in both projects, project A and project B. And then we're also given the cash inflows for year one, year two, year three, and project B as well. We're given the betas of each project, beta for project A and beta for project B, and we're given the risk-free rate, right? And we've been asked to calculate three things. Firstly, they want us to calculate the risk-adjusted discount rate for each project. Next, they want us to calculate the NPV based on the risk-adjusted discount rate, meaning we're going to discount these cash flows, CF0, CF1, CF2, CF3 for project A, CF0, CF1, CF2, CF3 for project B. And then we're going to calculate the NPV using the risk-adjusted discount rate. And then lastly, I asked which project would you choose based on your calculation. So maybe you can put the recording on pause. Try to use this formula right here to calculate the risk-adjusted discount rate. And then after getting the risk-adjusted discount rate, try to use your calculator to see if you can calculate the NPV of this project and the NPV of this project. And then when you've gotten your answer, you can check with the answer that I have. Okay, so I hope you gave that a try. Let's see what answers you got, and let's compare them with the answers that I have. Okay, if you look at my answers, I have the following answers. For the risk-adjusted discount rate for project A, it's 12.8. I hope you got that. And for project B, it's 11.6. So you use this formula right here. You can change these to percentages if you want, but to decimals, but I recommend that you just leave them as they are. And then you get the following answers. And then after getting these answers, you then input these values into your calculator. Remember to put this as a negative. You also put this as a negative. CF1, CF2, CF3. You calculate your NPV. By now, you should be comfortable with your calculator when it comes to the NPV. If you're not, you need to contact me, or maybe we can discuss the next time we have a class. So we get these two different NPVs, and then we would pick project A because of its higher NPV. So in summary, you see we had two different projects, and these projects are risky projects. And because of that, we used the risk-adjusted discount rate to calculate the NPV of these two projects, right? And also, very importantly, when we did this, we first calculated our risk-adjusted discount rate. Then we discounted these two different projects using different risk-adjusted discount rates because of their different riskiness. And then we pick project A because it has a higher NPV compared to project B. So that's how risk-adjusted discount rates work. We are no longer using the cost of capital or one risk-adjusted discount rate. Topic 2 is going to be on calculating the cost of capital. So don't worry if you're not too familiar with that right now. It's also known as the weighted average cost of capital, right? So here's the final part of the question. Pick project A because project A has a higher NPV, okay? And also importantly, when we talk about risk in capital budgeting has to do with how uncertain cash inflows are. When we say that a capital project is risky, we're saying that the project is risky because there's uncertainty in these cash inflows. That 50,000, 70,000, 20,000, and that 80,000, 90,000, and 170,000. We can't predict these cash inflows accurate like 100%. It's always possible we might make an error, but we always know how to calculate our initial investment. That's today. There's no uncertainty with the initial investment, but there's always uncertainty with these cash inflows. So risk in capital budgeting has to do with uncertainty in these cash inflows because they come in the future, right? So that's just some important theory you need to know that could be asked in the exam. Risk in capital budgeting refers to uncertainty in cash inflows. Okay. After that, on Saturday, we looked at comparing projects with unequal lives, right? So sometimes you can have a 2-year project and you might be comparing it against a 10-year project and you want to decide which one to choose, maybe based on the NPV. So we have to take special care when it comes to that. And the first statement says projects with unequal lives have different risks and we cannot use the NPV to accurately compare these projects. So if we're trying to choose between two projects, we can't accurately use the NPV to choose between two different projects if those two different projects have different risks. So we use what we call the annualized net present value. We use the annualized net present value, and it's also known as the equivalent annual annuity. So if we want to compare between two different projects with different risks, we use the annualized net present value or what we call the equivalent annual annuity. to accurately compare these projects, right? So there's an example. I'll put it up on the screen. It's example 2, semester 2. Example 2, sorry. Semester 2, assignment 1. It's semester 2, assignment 1. Semester 2, assignment 1. Yeah, there we go. Semester 2, assignment 1, 2020, question 2. Yeah, question 2. Okay. So this question, sorry, let me put up. So in this question, we're given three different projects: Project X, Project Y, and Project Z. And we're given the initial investments of each project. As you can see right here, initial investment is 780, 520, 660. And you can see that these projects have different lives. This project is a 4-year project, Project X. Project Y is a 2-year project, and Project Z is an 8-year project, right? So these are different projects with different lives. Then firstly, we are asked to calculate the NPV of each project over its life and to rank these projects in descending order on the basis of the NPV. Then we are asked to calculate the annualized net present value and to also rank these projects based on the annualized net present value in descending order. And then we are asked to compare the two projects. So for practice, you can put on pause. Please calculate the NPV of each of these projects, right? And try to see if you can get the NPV of each project. And then after getting the NPV of each project, try to get the annualized net present value. We did this last time. It's in your notes. Put the recording on pause, try to do those calculations, and then you can compare the answer you get with the answer that I'll put up on the screen. Okay. So I hope you did the calculation, and I hope you got the following answers: the NPV of X, the NPV of Y, the NPV of Z. By now, you should be able to do these with your calculator. If not, you need to let me know or talk to someone who can help you, maybe one of your colleagues or friends, fellow students, or you should contact me in the next class. And then if we rank these projects, Project Z is the highest NPV, followed by X and followed by Y. And then if we calculate the annualized net present value, we get the following answers for A, for X, for Y, and Z. Please remember that when we put PV, we usually put PV as a negative, right? You might know from your financial calculation. And then our PMT, our annualized net present value, will come out as a positive answer. But don't be too confused by whether or not to put your ANPV as a negative or positive. Don't be too worried about that. All you need to remember is that if your NPV was positive, your annualized net present value will also be positive. And if your NPV was negative, your annualized net present value will also be negative. So they always have the same signs. They will always have the same signs. Whatever your NPV gives you is what your annualized net present value will also give you. Okay, so we can also rank these in order, and we see that Project Y has the highest annualized net present value, followed by Project X, and lastly Project Z. So this is what we were trying to illustrate. These projects have different lives. If you calculate them based on the NPV, we are getting Project Z having the highest NPV, right? So we would pick Project Z based on the NPV. But if you calculate them based on the annualized net present value, we get Project Y having the highest annualized net present value. So we would pick Project Y. So when projects have unequal lives, we should choose our project based on the annualized net present value. It's more accurate compared to the NPV. The NPV is not an accurate measure when your projects have unequal lives. So when we're dealing with projects with unequal lives, we should use the annualized net present value. We should use this approach where we change our NPV into an annual amount, and that way we'll get a more accurate answer. So that's some important theory on comparing projects with unequal lives. Do not use the NPV, but rather use the annualized net present value. Okay. Lastly, on Saturday, we talked about an important concept that's known as the certainty equivalent approach, or the certainty equivalent CE approach. And this is a method, it's another method dealing with risky cash flows. And this is a method of changing risky cash inflows into riskless cash inflows. So let's say you're receiving cash inflows and they have risk and uncertainty. We can change these into risk-free cash inflows. We can move the risky part associated with the cash flow. And the way we do this, we change these cash flows to riskless cash inflows, and then we discount them using the risk-free rate to get the NPV. So we change these risky cash inflows into riskless cash inflows, cash flows without risk, by multiplying the risky cash inflows using what we call certainty equivalent or certainty equivalent coefficient. Okay, so let me just repeat that. We start with risky cash flows with risk. We multiply them by what we call a certainty equivalent, and that changes them to riskless cash flows or risk-free cash flows. And then we take these risk-free cash flows and we discount them using the risk-free rate to get the NPV. So there's also an example at the back of your study guide in study unit 3, working with certainty equivalence, but I've put my own example here. So consider a project with the following cash inflows and the initial investment of 10,000 Rand. Then we're given the project. So in year 1, the project will give us 4,000, year 2, 4,000, year 3, 3,000. And then these right here are the certainty equivalent coefficients, also known as certainty equivalent probability coefficient, right? Then we're told if the risk-free rate is 10%, determine the NPV of the project using the certainty equivalent approach. Okay, so with the certainty equivalent approach, what we do, we multiply each risky cash flow by its certainty equivalent coefficient. And then if we multiply 4,000 by 0.9, we get 3.6, 4,000 by 0.8, 3.2, 3,000 by 0.6, we get 1.8. So these cash flows are now riskless. We then take these riskless cash flows and we calculate the NPV of these riskless cash inflows using the risk-free rate of 10%. Again, try to put this calculation into your calculator, starting with a negative 10,000, and then enter in these cash flows and see if you get this answer of minus 2,730. So it would mean, based on the certainty equivalent approach, we would not accept the project because it has a negative NPV, right? So in conclusion, we looked at NPV profiles, and after looking at NPV profiles, we looked at comparing projects with different lives, the annualized net present value, and we concluded by looking at the certainty equivalent approach. So these are all, and also we looked at the risk-adjusted discount rate. So these are all concepts which are really important, which could be asked in the exam. Make sure you know the theory behind these concepts. If you're not able to calculate your NPVs by now, please let me know, or your internal rates of return, send me a WhatsApp or ask one of your fellow colleagues or fellow students. You need to be comfortable with these. We are now done with cash flows for now and capital budgeting techniques for some time, because we're now focusing on topic 2 from next week onwards. But what you can do, look at question 2.1 as homework from semester 2, assignment 1, 2019, just for practice, so that you get familiar with risk-adjusted discount rates, and how risky projects and how projects can be different in terms of riskiness and how we deal with that. Okay, so that's the end of this recording. I hope it's been beneficial. Just try to make sure you don't fall too far behind when it comes to what we're doing, and stay in touch. Thank you very much. So